Today's Daily Dose of Math is about Principles 4, 5, and 6 for the Math 4153 Geometry course. This course has a list of principles which are attached to the exam, and that is an advantage for the student because if the student has a situation where they have to apply one of these while doing one of the questions in the exam, instead of having to write out this long sentence to justify the step that they did, they're able to say, I used principle 4 or I used principle 6, whichever one they applied. And this is a time saver. Let's look at these principles. These are three principles that are used to judge whether two triangles are similar. Principle 4 says, if two angles of one triangle are congruent to the two corresponding angles of another triangle, then the triangles are similar. That is the old AA rule that I was used to calling it from an old geometry course I used to teach. It means the same thing. Principle 5 says, if the lengths of the corresponding sides of two triangles are in proportion, then the triangles are similar. And that is what we used to call the old SSS rule. It means side, side, side. And AA means angle, angle. Principle 6 says, if the length of two sides of one triangle are proportional to the lengths of the two corresponding sides of another triangle, and the contained angles are congruent, then the two triangles are similar. Well, that's a long one, and I'm glad if I don't have to write all of that out in an exam. But that is the old SAS rule, side, angle, side. What I have here are three fairly simple examples where we're being asked, are these two triangles similar? And then we need to justify our answer by using one of the principles. In the top one, both triangles have a 90-degree angle. One of them has a 30, the other has a 60. But we know that the three angles in a triangle add up to 180. So one thing that we'll do is we'll show what the missing angles are. In the first triangle, I say 180 minus 90 minus 30 equals 60 degrees. And at this point, I don't even have to do this step again for the second triangle, because now that I know the missing angle is a 60, I can see that both triangles have a 90 and a 60, and that's what principle 4 is saying. That means these two triangles have to be similar. So I'm able to say yes, and then I justify what I did by saying I used principle 4. And it's enough to just write the number with a circle around it to make sure to draw attention to it so that you get credit for justifying your answer. In the second example, all we know are sides. In the first one, we have sides of 80, 75, and 50 units. In the second, we have sides of 160, 100, and 160 units. And what we wanted to do is see if these form a proportion. I like to call this a triple proportion. If we put the, say this 160 over this 80, put the other 160 over the 75, and put the 100 over the 50, and then simplify, what we're getting is this simplifies to give 2, this doesn't give 2, this one gives 2. It was looking good for the first pair and the last pair, but the middle pair is not simplifying to give me a 2. It would actually simplify to give 32 over 15, which is pretty close to 2, but it's not 2. So what we have proven here is that the answer to our question is going to be no, because we need all of the pairs of sides to be in proportion for it to work. And my justification for saying no, besides showing my math calculation, is to say I'm applying principle 5. In the third example, we have a 100-degree angle between two sides of 6 units and 4 units. The other triangle, we have a 100-degree angle again in between sides of 3 units and 2 units. The 100-degree angle part is fine, and that's agreeing with the rule given in principle 6. But I need to take a look at these side lengths. I can say that 6 over 3 is equal to 4 over 2. Both reduce to give 2. Those sides therefore are in proportion. I'm able to say yes. And my justification is that I used principle 6. Now these are rather simple examples, and there are many other scenarios that could happen. But the student shouldn't be worried about many scenarios. The student should be thinking, if I am familiar with each of these 3 principles that judge similarity in triangles, then I am able to adapt them to whichever situation I encounter. All I have to do is look at the information I'm given, decide which principle applies best to it, and then see if the information I'm given is following the rule in the principle or not. If it's not, I say no. If it is, I say yes. I justify my answer by giving the principle that I applied, and whenever necessary, doing small calculations like these. Remember also that if you're learning this same type of math, but in a different curriculum than the one where I'm teaching, you may have a list of principles and theorems in your course, and you may have these 3, but they may not be numbers 4, 5, and 6 in your course. As an example, I teach another course called Math 4273 that has the same 3 principles, but they are not 4, 5, and 6 in that course. They are 5, 6, and 7, because there are a different number of principles in the other course, and it changes the numbering system that's used in the list. So just be careful to use the list of principles or theorems that goes with your course. That is today's Daily Dose of Math. Please subscribe and share, and don't forget to click that thumbs up button.